continue on in lesson 5.1. Now we're going to learn how can we set up a system of equations, and then we're going to use both a table and a graph to help us problem solve. So we have Bill and his brother who are collecting comic books. Okay? Bill currently has 15 books, and he adds 2 to his collection every month. Then we have his brother who currently has 7 books, and he's adding 4 books to his collection every month. It says write equations below to find the number, here's where I'm at, write equations below to find the number of months. So look at what it says right here, x. It's telling us that x is going to represent the number of months. Would you underline that, please? After which Bill and his brother will have the same number of books, y. So the y is going to represent how many books they each have, total number of books they each have. So we have already been told what our x is going to represent and what our y is going to represent. So what we're going to do now is we're going to set up equations that would represent each of these guys' collection. Okay, so let's talk about Bill's first. Number of comic books in Bill's collection. What equation could we set up that would help us problem solve when they have the same number of books? So remember, y is representing the total number of books, x is representing the number of months. Trey, what do you think?
The equation x, no, y equals. So both of them or just one?
We're just talking about Bill right now.
Okay, y equals 15 plus 7x.
Okay, I'll just write it down as you said it. Is this what you said?
Yeah.
Okay, Bill.
2x, because he adds 2.
So we're going to change the 7 to a 2. Is that what you're saying? Okay. So, okay, what do you think, class? Do you think that equation would work for us to be able to represent Bill's collection? Y, total number of books, is equal to 15, just a one-time thing because that's how many he starts with. And we're used to that language. The y-intercept shows us where we're going to start on the graph. Plus 2x, or in other words, our slope is 2 because he adds 2 every month, and x represents the number of months. That's pretty good, isn't it? Okay, now all of you write down the equation that you think would be the one for on your paper for his brother's collection. Write an equation for the brother. Maybe you want to finish Bill's first. Okay, we thank Trey for offering up the first equation for us, but now he doesn't get to offer up the second one. So who's going to, with a hand, that I can call on them, who wants to offer up what they think would be a good equation for the brothers' collection? Okay, brothers' collection. Anything, Shmarky?
Y equals 7 plus 4x.
Okay, y equals 7 plus 4x. How many of you agree with Shmarky's equation? Do you think that's a good one? Okay. Yeah. Total number of books in the brothers' collection should be 7, the amount he starts with, plus the 4 that he's going to add every month, so that's our 4x. 4 is our slope. Okay, let's make a table. In other words, let's find the y values by putting together a table. So let's make this Bill's column, and this can be the brother, okay? So in Bill's, we have y equals 15 plus 2x, and in the brother, we decided y equals 7 plus 4x. And I've chosen some x values for us, or in other words, x, remember, is representing what again? What are those x values representing? Like that 0, that 1, 2, 3, 4, 5 I have in it. That's the number of months, isn't it? Okay, so at 0 months, we would put 0 in for x, take it times 2, and add 15. So let's just do all this. Let's do some mental math here. What's 2 times 0?
0,
0. What's 0 plus 15?
15.
15, okay. So we have a 15. So we would say in this one, our y value would turn out to be 15. Which should make sense, right? Because we said at the start, Bill had 15 books. Before any time went by, at the start, Bill had 15 books. Okay, how many books did the brother have at the start then at time 0?
7.
7 books. So if we put 0 in for x, 4 times 0 is 0, and 0 plus 7 is 7. Okay, go ahead and fill out the rest of that table. Go ahead and do the calculations that will tell you how many books will be in each of their collections as you go along here. So you're substituting the x values into your equation and calculating what your y value should be. That's really what we're finding in our table. What's really happening in the column for Bill? What happens to the y value? JC?
You just go up to,
You just go up by 2. He's adding 2 every month, and since the months are going up a month at a time, we should be able to just keep adding 2, right? Okay. What's really happening in the brothers column then, Isaac?
You're adding 4.
Here's adding 4 because he keeps adding 4 to his collection every month, and the months are going up by 1, so you would say, oh, okay, well, I should just be able to keep adding 4, and I will have the brothers' total number of books in his collection. So do your tables, does your table agree with my table? Are you on the same page here? Okay. So we've made our table. Now step 2 says find a solution. Or in other words, we're looking for when these two guys have what?
The same
Number of books. How long does it take for them to have the same number of books?
4 months.
So we need to find the x value that gives the same y value. Let's go to our table and let's show that actually right here in the table, they have the same number of books, don't they? They both have 23. So find a solution, we are saying or we could say after 4 months. Let's do it that way. After 4 months, they have 23 books each in their collection. After 4 months, they're each going to have 23 books in their collection. We found the time and actually the number of books. Okay. Says use your answer to step 2 to find the number of months. Well, I guess we answered that already in the other step, didn't we? Yeah. So we were really only supposed to give the x value, I guess, in this one, which is 4 months, or I'm going to guess what it was supposed to be. I don't really know what it was asking for. That's why I'm cleaning that up. Okay, so we really have interpreted it already. We found the solution and interpreted it all in this one step, okay? Conclusion. When Bill and his brother have the same number of comic books in their collections, how many books will each have? 23. Again, we already said that up there, but let's just say there's 23 books in each of their collections. You want the rest of my cake. And now it says we're going to graph the equations on the same coordinate plane and see what we notice about the graph and this solution. Does anybody have any predictions? What should happen on the graph? Any ideas? Okay, then let's just go see what happens. Okay, so here's our coordinate plane, but we have to get it finished, getting it set up here first before we can start graphing. What's going to be on our x-axis again? What's our x representing?
Months.
Months, so the number of months. So would you fill out the rest of the title for that? Number of months. And what's on our y-axis?
Books.
Number of books. Now let's also test remember that sometimes coordinate planes can't go by ones on the x-axis and ones on the y-axis. Sometimes we have to change them so that we can make them more user-friendly. So in this case, I've kind of started it for us. I've said, this little, what does this little mark show right there? What's that really saying? Cameron?
It skips up to 7.
It skips up to 7. In other words, it's scrunching from 0 to 7 in that one spot. There's no representation for those numbers right there. So this is still 0 down here in the corner, but it is scrunching it up saying we're really just going to start at 7. What's the scale that it's going by on the y-axis? Or in other words, how many books is it going by at a time on the y-axis? Josh?
We have two.
Be careful. Let everybody revisit this and think about this. Look at it. Remember, just because there's certain ones labeled, that doesn't mean that's what the scale is. Scale means what does every grid line represent. So do we want to say every grid line is 2 books? Are we still going to say that? Right? What do you think?
Well, after 7 it'll go up by 2, but from 0 to 7 it's starting at 7, yes.
Yeah, we don't have to worry about this part. This is kind of like we're eliminating that part of the y-axis. We're saying we're going to start at 7, but then when we go up to this grid line, what's the number right here of this grid line really, Stefan? 8. This is 8 right here. So every grid line is really, when we're going up, it's going up by 1 book. It's only going up by 1 book, so we have to be careful. We want to make sure, even though every other one is only labeled. So we go by 2s just with the labeling, but the grid lines are really representing 1 book at a time. And the reason that sometimes we skip labels is because it just gets so busy. But if you want to label every one, we certainly can. Okay, so finish this. Finish labeling up your y-axis. You have to have a good graph that is easy to read. Somebody should not have to be counting while they're looking at your graph. Okay. Well, what scale is actually being used on the x-axis?
1.
Is every grid line representing 1 month? Oh, what's it representing? Half a month. Every grid line is actually a half a month. So we have, this is a half right here, really. Just labeling the whole months. So 1, 2, 3, let's finish labeling across. You skip grid lines because every grid line is really only a half. And you label. Doesn't mean it's going by 1 month at a time. It's just we're labeling the 1 month only, the whole number of months. But the scale is actually 1/2, which we have to take into account when we're doing our graphing, okay? So now that we have our graph set up, let's take our equations that we have from the front. Let's write down Bill. Remember, Bill's equation is what? JC?
15 plus 2x.
Y equals 15 plus 2x. Okay. And for graphing, what do we need from that?
M and the B.
The M and the B. So we're going to get the M and the B from it. What's the slope of this?
2,
2. And the y-intercept?
15.
15. Okay, this is where it gets tricky. When we change the scale on the x and the y-axis, on the y-axis, we're used to, it's going by ones. We're used to that, but it's not going by ones on the x-axis, is it? Okay, so we have to take that into account now when we are actually graphing it. Okay, so where are we going to start? We can still start where we want to, it says we're going to start at 15. Okay. Now, be really careful though, because if the slope is 2, that means go up to and over 1. Should we only go over 1 grid line? 1 month. Okay, so we have to, so we're going to go up 2 books. So let's think of it like this. This is up 2 books. Let's write that down so we can see. Up 2 books and write 1 month. It's a better way to think of it. So we're going to go up 2 books and we're going to go write 1 month. Okay? So a little bit different than we've been doing when we didn't know what the equations were representing. So up 2 books, we go to 16, 17 over a month. We'd have to go half a month, whole month. We actually end up going up 2 over 2. Up 2 books, over a whole month. Keep doing that. Make points so you can't make them anymore on that graph, okay? Some of you must have rulers already. Are there some of you that I'm handing out rulers to you wrong? You already have them, because I'm short rulers. I got stuff here.
I might have one in my room actually.
Or we grab, can you just grab it
Yes.
on the bottom drawer or
I
something?
think I do.
Okay. And again, just like we did when we were graphing these systems of equations without knowing what the equations were representing, we draw a line right away so we know what those were, that those points belong together, okay? After we're done graphing Bill's line, now we'll graph his brother's. Okay, so let's do the brother. We don't know what the brother's name is, so we just gotta call him brother.
I put bro for short.
Okay. Y equals, what's his equation?
7 plus 4.
7 plus 4x. Well, that means the slope for this one is what then?
7.
4. And the y-intercept, the starting point is
7.
7. Okay. Before we even graph it, let's again talk about that slope. That means what? What does 4 mean?
You're going 4 up and
Up 4 books
over.
and over
Right.
1 month. So let's do that again. So this really means up 4 books and right 1 month. Because that's how many books, and that should make sense. Adding 4 books every month. Okay, now we're ready to go to the graph and start at 7 and follow that up 4 books over 1 month. Up 4 books, right 1 month.
Didn't you go over to?
I did go over 2, which is 1 month though, right? Because every grid line is how much? Half a month.
The exact same thing.
Half a month. That's why we have to be really careful. That's when we know what these are representing and the scales change, we have to talk about it. So that's why it's better to talk about it as months and books, like we were doing here. Okay? Because what ends up happening on our graph?
The lines intersect.
The lines intersect, and where do they happen to intersect at? What's the ordered pair name they intersect at?
23, 4.
What?
423.
423. Yeah, they happen to intersect at ordered pair 423. Isn't that a coincidence? Because what happened in the table?
It's the same.
Josh?
It's within 4 months, if you get 20.
Yeah. In the table at 4 months, they both had 23 books. And this is telling us the same thing. On the graph, it says when you have your endpoint of intersection is at 423, 4 being the number of months, 23 being the number of books. Okay, now we're going to do some analyzing with that. Number 3A, it says, how can you tell by looking at the graph when Bill has fewer books than his brother? I think one of the things that would be good for us to do right now is decide, let's give each of those lines their name. This is Bill's graph, and this one is the brother. Okay? So Bill's is the one that starts up higher, and the brother is the one that starts down lower. Okay, so the question is, how can you tell by looking at the graph when Bill has fewer books than his brother? How can you tell by looking at the graph when Bill has fewer books than his brother? Bill. Okay, can you tell? Trey, what can you tell?
Two ways. One, when they intersect.
Does he have fewer books? Does he have fewer
They have
books
the
than his
same,
brother when they
no,
intersect?
they have
That's
the same.
when they have the same, okay?
And his brother's line is steeper.
And his brother's line is
So they're
steeper,
one higher.
okay? So does that tell me then that the whole, everything on the line except the point of intersection is when Bill has
No,
fewer
no,
books?
like at that line, like I'm just saying that that's how you know it's going to be.
So like, what, after they do intersect at this point, is Bill's got fewer books than his brother? What's true about the graph then? The line is below, okay, so how can you tell when Bill has fewer books than his brother? The line is below his, whoopsie. That's not his, that's his again. The line is below his brother's line where Bill has fewer books. Or in other words, after how many months does Bill have fewer books than his collection? After what? Taylor? 5 months and beyond, after 12 months, right? 5 months and beyond, that's when Bill's collection is smaller than his brother's, because the line is lower there. Really? How can you tell when the brother has fewer books than Bill? Right? When the brother has fewer books, when would that be?
3 months.
Yeah, so from at this point of the graph, right? This is when the brother has fewer books because his line is below Bill's. So the brother's line is below Bill's. So in other words, again, we're looking for the line is below Bill's line where the brother has fewer books. So in the beginning, Bill's collection is larger, which should make sense, because he started with more, right? But then all of a sudden, his brothers catches up to him, and when does his brother catch up to him again? After 4 months, and then they both have 23 books in their collection, and then what happens after that? Now the brother takes over, the brother's collection is getting, will Bill's collection ever catch up to his brothers again? Why not? Can the two lines ever intersect again? No, there's only intersect in that one spot, Anthony. So there's only that situation. Okay,